Hello everyone, this is lecture 5. In this lecture we will learn descriptive statistics and regression. In descriptive statistics we will talk about how to describe big data using numerical methods, and then we will learn how to describe it using graphical methods. And one part of graphical methods is to drawing a regression line which represent the linear relation between two numerical variables. Describing data numerically. Describing data numerically, we will learn in two parts, by central tendency and by variation. Central tendency is the typical or central numbers. Variation is amount of dispersion of scattering of numbers away from a central numbers. Here is measures for central tendency and variation. In central tendency we will learn arithmetic mean, median, mode, and in variation range, interquartile range, variance, standard deviation, and coefficient of variation. First, let's start with measures of central tendency. Arithmetic mean. The mean is the sum of numbers divided by the number of numbers. The formula for sample mean is this. Sample mean we sign by x bar, it means x line on the top, equal to fraction. In numerator, you write the sum of all values in your sample, and in denominator, number of values in the sample. Here xi represent values in the sample, and x bar represent sample mean. Median is the second measure of central tendency. Median is the middle value among the ordered numbers. What does it mean? It means that if you have ordered numbers and if you find out the median, half of the numbers smaller than or equal to the median, and half of the numbers larger than or equal to the. In the process of finding median, we must consider two possibilities. If data set contains an odd number of numbers, the number of numbers in the sample is odd, then the median is a middle number in ordered array, of course, in ordered numbers. If data contains an even number of numbers, the median is the average of two middle numbers. The last measure of central tendency is mode. Mode is the number in the set of numbers that appears most frequently. Sometimes you can consider that there is no most frequent number. Then we must say that there is no mode in this sample. Let's consider example for measures of central tendency. The numbers below shows the time to get ready in the morning in 10 consecutive days. 39, 29, 43, and for the last day, it takes from you 35 minutes to get ready in the morning. Find the measures of central tendency and interpret their meaning. In order to find the mean, we add up all these numbers and divide by 10. It's give us 39.6. The mean is 39.6, represent the average of the time to get ready in the morning. Median. Sometimes students make mistake finding median directly without putting the numbers into order. For example, if you take 39 and 44 and divide it by 2, it's wrong answer for the median. To find the median, first you must put the numbers into order. Into order, it means that you must put the numbers from the smallest one to the highest one. Only after that, select two numbers in the middle and then divide the result by 2. Middle two numbers for our data is is 39 and 40, middle number for data. If you put them into order, 39 and 40, if you find the average of these two middle numbers, it gives you 39.5. Why we find the average of middle two numbers? Because the number of values in this data is even. If the number of values was odd, then we take directly middle number after putting them into order. But in this case, you should add middle two numbers and divide it by 2. Finally, we have the result 39.5 for the median, which is very, very close to mean. It's a good situation when the median and mean equal to each other. What about the mode? In this data, there are two most frequent numbers. It's 39, you see here 39, 39, and 44. Because the mode is not unique, we say that there is no mode for this data. There is no mode. Because because in order to mode being exist, we should have just one most frequent number. There is no mode. Finally, we can say that if you knew the typical time it takes you to get ready in the morning, you might be able to better plan your morning and minimize any excessive lateness or earliness going to your destination. Now let's talk about the measures of the variation. The first measure of variation is range. Range is the difference between the largest and smallest numbers in our data. Second measure of variation is interquartile range. In order to understand the interquartile range, we should learn first quartiles. Quartiles, three numbers which divide the ordered numerical data into 4 equal parts. In each part, we have 25% of the data. Here is 3 quartiles, as you see, Q1, Q2, and Q3, which divide the numerical data into 4 equal parts. Now let's explain the meaning of these quartiles. First quartile is the value for which 25% of observations are smaller. You see here 25% of numbers smaller, and 75% of values are larger. Second quartile is the number from which 50% of values smaller and 50% larger. As you see, this is exactly same definition with the median. Therefore, Q2, second quartile, is the same as a median. Third quartile is the value from which only 25% of values greater than, and of course 75% of values smaller than third quartile. Now we can talk about interquartile range. Interquartile range calculates the length of middle 50% of the data. Formula for calculating interquartile range is that from Q3, the third quartile, you just need to subtract first quartile. Here is example about interquartile range. Suppose that we have a data which you cannot see here, but it's already calculated that minimum number in this data is 12, maximum is 70. First quartile is 30, second quartile and the median equal to 45, and the third quartile is 57. By the definition, interquartile range equal to 57 minus 30, 27. And what is range? Range is 70 minus 12, which gives you 58. Range, maximum minus minimum, interquartile range, Q3 minus Q1. You understand that from the picture we can understand that range is the range of all data is 100% of the data, all of them, because you subtract from maximum minimum. And interquartile range of middle 50% of the data. Sample variance. It's average of squared deviation of values from the mean, calculated using the formula. We sign it as s squared, and it's equal to the fraction. In numerator, we subtract from each value of our data sample mean, find the square, and sum all of these squared differences, and then divide it by n minus 1. They say here average approximately of squared deviations, because in denominator instead of n we have here n minus 1 for sample variance. Okay, this is formula for calculating sample variance, where x bar sample mean, xi numerical values in the sample, n sample size, and s squared together with the square. This represents sample variance. Now let's explain why in denominator of the sample variance we have n minus 1, not n. If the denominator were n instead of n minus 1, formula of variance would compute the average of squared difference around the mean. However, n minus 1 is used because s squared sample variance has a certain mathematical properties that make it desirable for statistical inference, for statistical calculations. As the sample size increases, the difference between dividing by n and by n minus 1 becomes smaller and smaller. Therefore, for large values of n, you get the same result, approximately same result for sample variance with denominator n or with denominator n minus 1. After understanding sample variance, we can talk about sample standard deviation. Sample standard deviation is the square root of sample variance. Formula calculated like this. As you see here, we sign the sample standard deviation as s equal to square root of sample variance. Here x bar represents sample mean, xi numerical values in the sample, all of the values in the sample, n represents sample size, and s without the square represent sample standard deviation. Let's consider example about finding sample variance and sample standard deviation. Suppose that we have 8 numbers here. We want to calculate these two things. In order to find the sample variance, we must know that the number of values. Here we have 8 numbers, therefore sample size n equal to 8. Next thing, for the variance, we need to find sample mean, which we sign by x bar. Sample mean equal to sum of values in the sample divided by number of values. We obtain there 16. Next thing, from each number, you subtract sample mean, find the square. You see, 12 minus sample mean square plus 14 minus sample mean square plus, and the last 24 minus sample mean square. And then divide this sum by n minus 1, where you will take instead of n 8, and instead of sample mean x bar 16. You see, we take instead of x bar 16 and instead of n 8, we obtain 130 over 7. This is the result for sample variance. Now let's find the sample standard deviation. As you know, sample standard deviation is a square root of sample variance, which is square root of 130 over 7, and the approximate value of it is 4.03. Sample standard deviation represent average scatter around the mean. Let's consider example where we will compare standard deviation of 3 different data sets. Suppose that we have a data A where the numbers is 11, 12, 13, 16, 16, 17, 18, and 21. If it's already calculated for you, but if you want, you can calculate yourself. Mean for this data equal to 15.5 and standard deviation by using the previous formulas equal to 3.38. Data B consists of the numbers 14, 15, 15, 15, 16, 16, 16, and 17. Mean for this data again equal to 15.5 and the standard deviation calculated as 0.926. And the third data is data C. Here we have 11, 11, 11, 12, the next number 19, and then 20, 20, 20. For this data, again, mean equal to 15.5 and standard deviation equal to 4.57. These three data is selected like mean for all this data equal. Mean equal, but standard deviation is different. Now let's explain what does it mean the highest, the great value for the variance. What does it mean? What does it mean the smallest number? And what does it mean the middle number? As you know, for all these three data, mean equal to 15.5. In numerical axis, it's approximately here. For data A, you see that the distance from the numbers to the mean is more than distance from the numbers to the mean in data B. You see here numbers very located very close to mean, but here they away from the mean. But here in data C, they are far away from the mean, in very great distance from the mean. And what is the conclusion then? Look at the sample standard deviation for all these three data. Here we have a smallest standard deviation. This occurs when the values in the data set very close to mean. Here they are a little bit far away from the mean. But here all of the numbers far away from the mean. Therefore here we have the high standard deviation. Here we have the smallest standard deviation. This again explain us what standard deviation calculates. Standard deviation calculates the average of distance from the mean. If the standard deviation is bigger, it means that the values in the data set far away from the mean. If standard deviation smaller, it means that values in the data set very close to mean, as in B. Now we can consider these three data as an average of a student. For example, here we have every kind of student. You see, students in this class we have with 11 point, with 12 average point, with 13, with 16, 17, 18, and 21. Here, the average of students located between 14 and 17, we don't have any numbers far away from the mean. And in this C, all averages of students far away from the mean. What we have in the class C? In class C, we have very good students whose grade is 19, 20. We have very bad students here with the average 11 and 12. In this class, we don't have very good students and we don't have any bad students. This students is a middle students here in this class. For this class, we have every kind of student. And As you see, if you make an exam for this 3 class, the mean give us same result, but it doesn't mean that these class are same. For the teacher, it's good to teach the class B because the level of students in this class is same. And in class A and class C, we have a bad situation because we have each type of student here, and a worse situation in class C. We have good students, teacher can work with these students, and then these students cannot understand anything from the lesson, or vice versa. If teachers start to teach these students, for the high level students, this topic or this kind of teaching methods will be bothering them and they will not like it. The coefficient of variation. Coefficient of variation, denoted by the symbol CV, measures the scatter in the data relative to the mean. As you see, they use the first letters of the words coefficient and variation to denote coefficient of variation. Calculated using the following formula. As you see, we use the fraction to calculate it. We divide standard deviation by sample mean. Standard deviation has the same unit as original data, but because you divide standard deviation to the mean, we obtain that coefficient of variation is unit-free. You can calculate coefficient of variation with percentage by multiplying this fraction to 100. It's used to compare scatter around the mean for two variables which measure it with different measurement system. For example, if you have a data which measures using the kilograms and the data which measures by centimeters, if you want to compare their standard, to compare their scatter around their mean, you have to use coefficient of variation, because standard deviation cannot compare this. You cannot compare centimeter with kilogram, but because coefficient of variation unit-free, you can use it for comparing variables which measures with different. That's all. Now we finish all measures of variation and finish the topic about describing data using numerical methods.